Level 0. Right now, about 20 miles above your head, something is saving your life. You can't see it, can't smell it, can't touch it, but without it, stepping outside would give you a sunburn in less than 5 minutes. Your eyes would start clouding over. Your immune system would slowly collapse. This is the ozone layer, and most of the time, it's doing its job perfectly. Ozone is just oxygen with an attitude problem. Regular oxygen, the stuff you breathe, comes in pairs, 2 atoms holding hands as O2. Ozone is 3 oxygen atoms crammed together as O3, and it's unstable, reactive, and weirdly enough, exactly what we need between us and the sun's fury. The ozone layer sits in the stratosphere, that quiet zone of atmosphere above where weather happens. Up there, ultraviolet radiation from the sun splits regular oxygen molecules apart, and sometimes those freed atoms grab onto other oxygen molecules, creating ozone. It's a constant cycle, oxygen breaking apart and reforming, and in the process, it absorbs the ultraviolet radiation that would otherwise sterilize Earth's surface. At level 0, everything's balanced. Ozone is created at roughly the same rate it's destroyed. The concentration hovers around 10 parts per million, which sounds tiny until you realize that if you compressed all the ozone in a column of atmosphere down to sea level pressure, it would form a layer about 3 millimeters thick. That's it. 3 millimeters of unstable gas between you and radiation that would make the surface of Earth look like Mars. Ground-level ozone, ironically, is a pollutant, the main component of smog that burns your lungs and damages crops. But up in the stratosphere, it's humanity's guardian. It filters out about 97–99% of the sun's medium-frequency ultraviolet light, the UVB radiation that causes skin cancer, cataracts, and DNA damage. For most of human history, we didn't even know it existed. We just lived under its protection, blissfully unaware that we were one chemical innovation away from punching holes in our own shield. The ozone layer formed billions of years ago when photosynthetic organisms began producing oxygen, gradually building up this protective barrier that made complex life on land possible. But what happens when that protection starts to crack? Level 1. In the 1970s, scientists started noticing something weird. Ozone concentrations weren't quite where they should be. Not dramatically lower, just off. A few percentage points down in certain regions, like someone had turned down the volume on a radio just enough to notice. The measurements were subtle, easy to dismiss as instrument error or natural variation. At 0 to 5% depletion, you wouldn't see any obvious changes in your daily life. The sun doesn't suddenly feel hotter. The sky doesn't change color. But subtle shifts are happening beneath the surface. UVB radiation reaching Earth's surface increases by about 10% for every 5% of ozone lost. The changes are invisible but insidious, working their damage at the molecular level. Skin cancer rates start ticking upward, slowly at first. Melanoma cases increase by about 2 to 3% for each 1% decrease in ozone. UV radiation suppresses the immune system, making people more susceptible to infections. Your body's natural defenses weaken. Cataracts become more common, clouding the vision of millions more people worldwide. Crops like soybeans and wheat show marginally reduced yields, maybe 2 to 5% less productive. Plant leaves show increased damage, tiny lesions invisible to the naked eye but devastating at the cellular level. The plants struggle to photosynthesize efficiently. But here's what's terrifying. This level of depletion was already happening globally by the mid-1980s. We'd started depleting the ozone layer decades before we even realized we were doing it. The damage had been accumulating silently, invisibly, while we went about our lives. The culprits? Chlorofluorocarbons, or CFCs. CFCs were miracle chemicals. Non-toxic, non-flammable, stable, perfect for refrigerators, air conditioners, and aerosol spray cans. Companies like DuPont promoted them as revolutionary, safe alternatives to toxic refrigerants that had killed workers. By the 1970s, nearly 1 million tons were being produced annually. They seemed like the perfect solution to a real problem. And that stability was exactly the problem. CFCs don't break down in the lower atmosphere. They just float upward, slowly, over years and decades, until they reach the stratosphere where the real destruction begins. Up there, UV radiation breaks them apart, releasing chlorine atoms. One chlorine atom can destroy 100,000 ozone molecules before it's finally neutralized. It's a catalytic reaction. The chlorine isn't consumed. It just keeps ripping apart ozone molecule after ozone molecule like a relentless molecular serial killer. The chlorine atom steals an oxygen atom from ozone, O3, creating chlorine monoxide, ClO, and regular oxygen, O2. Then that chlorine monoxide encounters another ozone molecule, and the cycle repeats endlessly. The scary part about level 1 is how invisible it is. We were damaging our protective shield while spraying our hair and cooling our homes, completely unaware. But in one specific place on Earth, The damage was about to get so much worse that even satellites would see the wound. Level 2. In 1985, British scientists working at Halley Bay in Antarctica published measurements that seemed impossible. During the Antarctic spring, ozone levels over the South Pole were dropping by more than 40%. In a massive region over Antarctica, the ozone layer was vanishing. The data was so extreme it seemed like science fiction. At first, people thought the instruments were broken. NASA had satellites monitoring ozone, and they hadn't reported anything this extreme. Turns out, the computer programs had been automatically throwing out the Antarctic readings because they were so far outside expected values that the software assumed they were errors. The computers had been programmed to ignore the impossible, and the impossible was happening. When they looked at the raw data, they found it. A hole. A region where ozone concentration had collapsed to less than 60% of normal levels, stretching across an area the size of North America. During peak depletion, some parts of the stratosphere lost 70% of their ozone. The numbers were staggering and terrifying in equal measure. Why Antarctica? The chemistry requires extreme cold, below -78 degrees Celsius, -108 degrees Fahrenheit, for polar stratospheric clouds to form. These clouds, made of ice crystals and frozen nitric acid, provide surfaces where chemical reactions convert inactive chlorine compounds into highly reactive forms. It's like the cold activates a chemical time bomb that's been sitting dormant. Throughout the Antarctic winter, which lasts 6 months, these clouds accumulate chlorine compounds on their surfaces. Then spring arrives. The sun returns after months of darkness. When spring sun returns, UV radiation triggers these chlorine compounds to start destroying ozone at catastrophic rates. Within weeks, ozone levels plummet. The destruction happened so fast that early observers couldn't believe the measurements were real. The Antarctic ozone hole became a visible scar in satellite images, a gaping purple wound in false-color ozone maps. Scientists could watch it grow in real time each spring, expanding from the size of Antarctica to covering an area larger than North America. At its worst, in the early 2000s, the hole reached 29 million square kilometers. At level 2, people living in southern Argentina and Chile started experiencing ozone alerts. Days when UV radiation spiked so high that going outside required sunscreen and protective clothing even for short periods. Schools kept children indoors during recess. Construction workers had to limit outdoor exposure. Sunglasses became mandatory equipment. The UV index, which normally peaks around 10 to 11, would spike to 15 or higher, levels that cause sunburn in under 10 minutes, even for people with darker skin. Sheep in Patagonia developed eye damage and blindness. Fish in Antarctic waters showed DNA damage. Phytoplankton, the microscopic organisms forming the base of ocean food chains, began suffering from UV stress. Their cell walls deteriorated. Their reproduction slowed. This wasn't just a human problem. It was ecosystem-wide. Every living thing under that wounded sky was paying the price. And here's the thing that should chill you. The CFCs causing this damage were already in the atmosphere before we discovered the hole. CFCs persist for 50 to 100 years. We'd already loaded the gun and pulled the trigger. But what if we hadn't stopped? What if the hole over Antarctica was just the beginning? Level 3. The Montreal Protocol in 1987 was the emergency brake. Countries worldwide agreed to phase out CFCs. But let's talk about what would have happened if we hadn't acted. This level represents the avoided future, the path we narrowly escaped. It's the nightmare timeline we dodged by mere years. At 40–60% ozone depletion, UVB radiation at Earth's surface would increase by 100 to 150%. This isn't just more sunburns. This is a fundamental shift in how dangerous sunlight becomes. The rules of outdoor life would be completely rewritten. Daytime would become a threat. Skin cancer rates would skyrocket. Melanoma diagnoses would double or triple. Cataracts would affect millions more people, causing widespread blindness. Immune system suppression from UV exposure would make everyone more vulnerable to disease. Hospitals would be overwhelmed with UV-related conditions. Emergency rooms would see constant streams of severe sunburn cases, radiation sickness, and acute eye injury. Medical systems worldwide would buckle under the pressure. Healthcare workers themselves would face higher UV exposure, creating staffing shortages. But the real nightmare is what happens to ecosystems. Phytoplankton, which produce half the oxygen in Earth's atmosphere, are extremely sensitive to UV radiation. At level 3, phytoplankton populations would crash by 30–50%. This would ripple up the food chain. Fish stocks would collapse. Ocean dead zones would expand. The oceans would begin to die from the surface down. Coastal communities dependent on fishing would face economic collapse. Billions of people who rely on ocean protein as their primary food source would face malnutrition and starvation. On land, Crop yields would plummet. Wheat yields could drop by 20–30% in affected regions. Rice, corn, and other staple crops would show similar devastating declines. Food prices would skyrocket globally. Nations would hoard grain reserves, creating international tension. Forest ecosystems would shift as UV-sensitive plants died off. Amphibians would face near extinction as UV radiation damaged their eggs and larvae. The Antarctic ozone hole would persist year-round and expand over populated areas. Arctic ozone depletion would worsen dramatically, threatening northern communities. Cities like Melbourne, Cape Town, and Buenos Aires would experience dangerous UV alerts throughout spring and summer. Outdoor activities would become hazardous. Tourism industries would collapse as beaches became dangerous zones. Scientists ran models showing that by 2050 to 2065, we would be at level 3 globally with devastating consequences. The ozone layer would have become a tattered remnant, more like Swiss cheese than a protective blanket. The models painted a grim picture: skin cancer rates tripling, food shortages affecting billions, ocean ecosystems collapsing. Some projections suggested that by 2100, the ozone layer could be depleted by 70% or more in temperate regions during summer months. We were on a collision course with environmental catastrophe, and most people had no idea. And if the damage continued beyond this point, we'd be looking at something Earth hasn't experienced in hundreds of millions of years. Level 4. Now we're entering territory that humanity has never experienced. This is where the ozone layer stops being degraded and starts being destroyed. This level is theoretical, based on scientific models of catastrophic scenarios like a nearby supernova. But theoretical doesn't mean impossible. It just means we haven't experienced it yet. At 60–80% depletion, UVB radiation would be 3 to 4 times higher than natural levels. This would fundamentally rewrite the rules of survival. Life as we know it would have to adapt or die, and most wouldn't adapt fast enough. Most terrestrial plants would die. Forests would collapse entirely. The Amazon rainforest, the Congo Basin, the boreal forests of Canada and Russia would all vanish within a decade. Grasslands would convert to barren scrub. Agricultural collapse would be total. Every major food crop would fail. Wheat fields would produce nothing but dead stalks. Rice paddies would yield only withered husks. Famine would be global and unavoidable. Civilization as we know it would crumble under the weight of starvation. Billions would die in the resulting famines and wars over remaining food. Ocean dead zones would expand across surface layers. With phytoplankton devastated, oxygen production would drop by half. The ocean, which produces more oxygen than all the world's forests combined, would stop breathing. Fish populations would crash. Coral reefs would receive a final killing blow as their symbiotic algae died from UV exposure. Amphibians would go extinct. Insects would see mass die-offs, collapsing pollination network. Without pollinators, even surviving plants would fail to reproduce. Birds and mammals that depend on insects would starve. For humans, being outside during daylight would become medically dangerous. Sunburns would occur in minutes. Even on overcast days, UV radiation would penetrate clouds enough to cause damage. Eye damage from brief exposure would be common. Retinal burns would cause permanent vision loss. Societies would be forced into nocturnal or subterranean lifestyles, emerging during daylight only with protective equipment, essentially living like vampires in a world that had turned against them. The albedo of Earth would change dramatically. With less vegetation, more bare soil and rock would be exposed, potentially accelerating climate change beyond current projections. This level represents an extinction threshold for complex ecosystems. Biodiversity would crash to levels not seen since the Permian extinction, when 96% of marine species died. But there's a level beyond this, a point where the ozone layer essentially ceases to function. Level 5. At 80–95% depletion, the ozone layer exists only as a trace. UVB radiation would be 5 to 10 times normal levels. UVC radiation, normally completely absorbed by ozone, would penetrate to the surface. This level is highly speculative, representing extreme scenarios like gamma-ray bursts. But Earth has faced gamma-ray bursts before, and it could face them again. This is a world where DNA itself becomes unstable in sunlight. The very code of life breaks down under the radiation. Every photon becomes a potential killer, shattering the double helix, scrambling genetic information, turning cells cancerous, or simply destroying them outright. Terrestrial life would be confined to caves and underwater environments. Surface layers down to 30 to 50 meters would be sterilized during daylight. Life would persist in deeper waters, collapsing into simplified food chains based on chemosynthetic bacteria near hydrothermal vents. The deep sea would become Earth's last refuge. For humanity, surface civilization would be impossible. We'd be forced underground into heavily shielded structures with meters-thick walls of concrete or soil. The few who ventured outside would need full-body radiation suits, similar to what nuclear workers wear but designed for UV protection. Agriculture would move to indoor facilities with artificial lighting, requiring enormous amounts of energy. Every calorie of food would become exponentially more expensive to produce. Water sources would need constant monitoring. UV radiation would break down organic compounds in surface water, creating toxic byproducts. Treatment plants would need extensive UV shielding. The genetic damage would be transgenerational, with reduced fertility and increased infant mortality. Birth defects would skyrocket. Geneticists estimate that mutation rates could increase by 50% or more, overwhelming our ability to treat genetic diseases. This level would require extraordinary circumstances: massive volcanic eruptions injecting chlorine into the stratosphere, asteroid impacts vaporizing chlorine-rich materials, or theoretical substances far more potent than CFCs. But the scariest part is that we've had near misses. In 1991, Mount Pinatubo erupted in the Philippines, injecting 20 million tons of sulfur dioxide into the stratosphere. For 2 years afterward, ozone depletion worsened temporarily. If that eruption had been richer in chlorine compounds, the damage could have been catastrophic. But here's the disturbing part. Earth has been at level 5 before, about 450 million years ago, during the Ordovician-Silurian extinction. A gamma-ray burst is theorized to have stripped away the ozone layer, killing 85% of marine species. Recovery took hundreds of thousands of years. And then there's the final level, the point where Earth's atmosphere becomes fundamentally altered. Level 6. This is the end state. The ozone layer is gone. Every last molecule of O3 destroyed faster than it can reform. This level is almost entirely theoretical but not impossible under extreme scenarios. And in the vastness of space and time, the impossible becomes inevitable somewhere, sometime. At level 6, all UV radiation from the sun reaches the surface unfiltered. Life on Earth's surface would end overnight. Not gradually, not with warning, but catastrophically fast. Bacteria would die within hours. Plants would wither in a single day. Animals exposed to sunlight would suffer radiation burns so severe that death would come as a mercy. Water molecules would be photodissociated by UV radiation, split into hydrogen and oxygen. Hydrogen would escape to space. Over geological timescales, Earth would lose its oceans. The same fate as Venus. We'd watch our planet die in slow motion, transforming into a barren desert world. The stratosphere would cool and collapse, merging with the troposphere. Weather would become unrecognizable. Storm patterns would shift dramatically. Surface chemistry would go haywire. Organic molecules would break down. The surface would become a photochemical reactor churning out bizarre compounds. Remaining life would be confined to deep oceans, caves, and subsurface environments. Humanity would need space station levels of life support just to survive. We'd become aliens in our own world, living in sealed habitats, entirely dependent on technology for continued existence. A nearby supernova could do this, destroying all ozone within hours. A gamma-ray burst would have the same effect. A rogue planet could perturb Earth's orbit closer to the Sunday. At level 6, Earth becomes a UV-scorched wasteland where the sky itself is a weapon. And the most terrifying part? We came within a few decades of starting down this path and most of the world had no idea.